Four-engine commercial aircraft like the legendary Boeing 747 and the super jumbo Airbus A380 have largely disappeared from passenger service, replaced by far more efficient twin-engine wide-bodies. On the surface, it looks like the era of the quadjet is over for good, but there are still several scenarios where demand for four-engine aircraft could return, even if only in limited and highly specialized roles. The world's busiest airports are facing increasing congestion, and available takeoff and landing slots are becoming harder to secure. When airlines can't add more flights, the only way to move additional passengers is to use larger aircraft. High-capacity quadjets can move enormous numbers of people in a single slot, making them well-suited for dense trunk routes between major global hubs where 500 or more passengers regularly travel on a single flight. Beyond passengers, the market for heavy and outsized cargo is not just strong but growing. E-commerce, globalization, and large-scale infrastructure projects are driving steady demand for aircraft capable of lifting massive or unusually shaped loads. Continued interest in the 747-8F and even legacy aircraft like the Antonov AN-124 shows how valuable four engines can be when operating at high weights from hot and high airports or on shorter runways. As global cargo volumes expand, especially for oversized shipments such as renewable energy components, aerospace hardware, and humanitarian relief, airlines and cargo operators see the business case for new multi-engine freighter designs. Four-engine aircraft also retain operational advantages on ultra-long-haul routes. While modern twin jets like the 777 and A350 are certified to fly far from diversion airports, very long polar or oceanic routes still present planning and operational challenges. Quadjets are not constrained by extended-range twin-engine operating limits, allowing more direct routings across remote regions. The additional engines offer a higher level of redundancy, which continues to appeal to safety-focused operators and some passengers, particularly as demand for non-stop flights over isolated parts of the world grows. For almost half a century, the 747 was an iconic symbol of intercontinental air travel. A combination of technology, economics, and regulation led to the demise of the 747, along with the Airbus A380 and Airbus A340 quadjets. The decline began as new high-thrust, high-bypass twin jets proved capable of hauling 300 to 400 passengers between any two cities under ETOPS. Boeing's final evolution of the 747, the 747-8, arrived in the late 2000s with a stretched fuselage and new GE-NX engines. Despite its improvements, demand never recovered. By 2020, Boeing confirmed the end of 747 production, with the final 747-8 freighter delivered in 2023, closing a chapter that began in 1969. The A380 followed a similar path. Launched in 2000, it was designed around the idea that traffic between major hubs would outgrow available airport slots. The aircraft could carry close to 600 passengers in a single movement, using the same runway footprint as smaller wide-bodies. However, by 2012, twin-engine aircraft like the Boeing 777-300ER and later the Airbus A350-1000 were delivering significantly lower costs per seat. Outside of its largest customer, orders dried up, and Airbus ended A380 production in 2019, with the final delivery completed in 2021. The A340 story took place even earlier. As fuel prices climbed in the early 2000s, the penalty for carrying 4 medium-sized engines instead of 2 large ones became impossible to ignore. Airbus attempted to revive the program with longer range and higher capacity variants, but sales stalled. The order book closed in 2011, and the last aircraft left the factory a year later. Despite these outcomes, four-engine aircraft still offer technical advantages that twin jets cannot fully replicate. A quad retains 75% of its thrust and onboard power generation after losing one engine, providing deep redundancy for propulsion, electrical systems, hydraulics, and bleed air. This can improve dispatch reliability on routes where alternate airports may be hours away. Spreading thrust across 4 smaller engines also allows airframes to grow without pushing engine diameters or temperatures to extremes, improving takeoff performance at challenging airports and enabling the lift of extremely heavy cargo. On designs like the 747, outboard engines even help reduce wing-bending loads. The 747 family highlights these advantages clearly. It can fly with one engine removed for maintenance and even carry a spare engine mounted under the wing. Its lifting nose door allows operators to load cargo too large for standard freighter doors, making it uniquely valuable for special missions. Today, it remains the preferred platform for government, military, and industrial roles that require exceptional payload capacity, electrical power, and redundancy. One of the strongest supporters for the 747 has been Atlas Air, whose fleet consists entirely of 747 variants. When the final aircraft was delivered in 2023, the company emphasized how deeply its global operations and success are tied to the type, which has served in hundreds of airports across more than 170 countries. As long as there is a need to transport cargo too large for conventional aircraft or to operate flying command centers that require the power and redundancy of a small city, the 747 will continue to serve in limited but vital roles. Its combination of speed, range, payload, and 4-engine resilience keeps it relevant long after passenger airlines have moved on. The A380, meanwhile, continues to attract interest from its most committed operator, Emirates. The airline's hub-and-spoke model allows it to fill hundreds of seats per flight, many in premium cabins. Emirates has repeatedly pushed for an A380neo, proposing new engines, aerodynamic improvements, and weight reductions to extend the aircraft's life and improve fuel efficiency. While Airbus remains unconvinced that demand beyond Emirates alone justifies the investment, the discussion highlights that in the right circumstances, very large aircraft can still make sense. 4-engine designs are also emerging in a very different form. Boom's Overture, intended as a next-generation supersonic airliner, uses 4 medium bypass engines to balance efficiency, noise, and performance. Unlike the iconic Concorde, it aims to cruise supersonically without afterburners, using modern composites and aerodynamics to achieve lower fuel burn and noise. While it serves a completely different market, it demonstrates that 4 engines still have a role in solving specific aerodynamic and operational challenges. Overall, the global aviation industry remains firmly oriented toward high-bypass twin jets for mainstream passenger travel. However, shifting infrastructure constraints, ultra-long-haul operations, specialized cargo demands, and emerging technologies could carve out renewed, if limited, specialized markets for 4-engine aircraft. Any return would likely focus on high-density routes, remote operations, heavy-lift cargo, or entirely new concepts, rather than a full revival of the quadjet era. What do you think? Could 4-engine aircraft develop a meaningful role again, or is their era truly over? Let us know by leaving a comment, and don't forget to subscribe for more aviation content. See you next time. In addition to our daily YouTube videos, Simple Flying publishes over 150 articles and a podcast every week. Visit simpleflying.com.